Bristol Community College, Mathematics with Dan Avedikian, Math 132, Calculus with Applications, Section 15.2, Problem 8. This is Section 15.2, question number 8. We want to solve the integral of dx over 6x plus 1. So this is very similar to the previous problem, number 7. If it was just dx over 6x, I could deal with that without using the substitution method. The plus 1 with the 6x in the denominator does change it. So I have to make a substitution. And the only logical choice really is what's in the denominator, the 6x plus 1. Again, the common choices of first being stuff in the parentheses, there are no parentheses in this problem, so that's not an option. Stuff in the denominator is a perfect match. Stuff under the root, there's no root. Power of e, there's no e. So it really has to be what's in the denominator. The u has to be 6x plus 1. So after that, we want to find du, which is the derivative of u. The 6x will give me a derivative of 6. Again, when I have an x to the first, the derivative is the number in front of the x, which in this case, positive 6. The plus 1 has a derivative of 0. So it's really 6 plus 0, which can be simplified to 6. And at the end, you put a dx for derivative with respect to x. So now as I go to rewrite my integral, the denominator is obviously a perfect match for u. The 6x plus 1 gets replaced with a u. The top doesn't quite match up. I need to replace dx. I have 6 dx. I want just dx. I need to get rid of the 6. So again, it's an equation, right? It's got an equal, so I can do whatever I want as long as I do the same thing on both sides. So on both sides, I will multiply times 1 over 6, times whatever I have to get rid of the 6. So on the left, 1 over 6 times du is 1/6 du. And on the right, 1 over 6 times 6 dx, the 6's cancel, and I have dx. Now, the dx that I want to replace, I know exactly what it's equal to. I have a perfect match. Dx is equal to 1/6 du. So now I have the original integral written in a form where I don't have the problem of having the plus 1 in the denominator. So let me clean this a little bit, this 1 over 6 that's in the numerator here. Again, since it's just a number, I can pull it out in front of the integral symbol. I get to do that because it doesn't have a variable with it. And then the u in the denominator, I prefer to write it as u to the negative 1. In general, you can't have a variable in the denominator when you're doing an integral. Now, as we saw in the previous problem, number 7, if I try to apply the formula that I usually use, what I would do is leave the 1/6 in front, and now I would have the 1 in front of the u that's not really written but understood to be there. And in the denominator, the previous exponent of negative 1 plus 1, u to the old exponent of negative 1 plus 1, and then plus a constant at the end. But when you go to simplify, you have in a denominator negative 1 plus 1, which is 0, which you can never have. You can never have a 0 in the denominator. So again, that's your flag that you can't use the formula with the n plus 1 in the denominator. So what you really have, that 1/6 in front, natural log absolute value of u plus some constant. That's the answer. We have to use the natural log when we have an exponent of negative 1 that we take the integral of. Again, negative 2, negative 7, negative 44 would be fine. Negative 1 makes a problem because it produces a 0 in the denominator. Now, that's the answer, but you can't leave it in terms of a new variable that you substituted in. You have to put back in the original variable, which for this problem is an x. So instead of 1/6 the natural log of u, it'd be 1/6 the natural log of what u is equal to, which is 6x plus 1. And to do a nice job, it really should be in absolute value symbols, because you can't take the natural log of a negative value. And you would have plus a constant at the end.